In this video, we will try to understand a new meta-heuristic optimization algorithm named as Freiberg algorithm. Freiberg algorithm is ranked in the top 6 optimization algorithms, and its performance is better than particle swarm optimization algorithm and genetic algorithm. As you can see here, this algorithm is introduced in 2010 by Ying Tan and Zhu. It is a swarm intelligence optimization algorithm that is basically inspired by the Freiberg explosion behavior in the real life. So as this algorithm is inspired by the Freiberg explosion behavior in the real life, so first we will try to understand about Freiberg explosion so that we can easily understand how this algorithm is working step by step using different examples. Fireworks are used during celebration or festivals in the real life. Fireworks include firecrackers, rockets, and multi-shot aerial fireworks. To make effective fireworks, pyrotechnicians carefully measure black powder, chemicals, fuses, and other materials. First, they mix powder with different chemicals and metal to make stars. In reaction to the heat from a black powder explosion, specific color is produced by the selected chemical. For example, by mixing copper into star will produce blue light, sodium create yellow light, copper create blue light, barium chloride is used to make green light, and calcium is used to make orange light. A small container filled with explosive chemicals that produce bright color patterns and loud noise explode. Freiberg algorithm simulates this Freiberg explosion behavior in the real life. Here we have the virtual environment like search space, virtual Freiberg as the search agents, virtual spark, and virtual explosion for the Freiberg, and we have the virtual sparks. So first we will initialize algorithm parameters. Next, initialize the position for n Freibergs randomly in the search space. Next, the equality, that is the fitness value, is calculated for each Freiberg. This is done to determine the explosion amplitude and the number of spark generated for each Freiberg. Set off n Freibergs and calculate the number of sparks that the Freiberg yields and obtain the position for the sparks. In Freiberg algorithm, we have two types of spark explosion and Gaussian spark. So spark explosion is simply generated by the explosion process, and the Gaussian explosion is generated by the Gaussian mutation. Next, we will evaluate the quality for the new locations that we obtained for the sparks, and we select the best among all and keep the best solution, and we will use rest and -1 in the next iteration for the explosion. We repeat this process from here, set of n Freibergs, until stopping condition is met, and in the end, when the stopping condition is met, display the best solution and its position that you found in the previous iteration. Now step by step we will try to understand how this algorithm is working. First, we will initialize the algorithm parameters like population size, that is the total number of Freibergs, search space boundary, that is upper bound, lower bound, total number of design variables, that is the dimension, maximum of iteration, that is how many times this loop will repeat. Next, we will initialize the position for the n Freibergs randomly in the search space. Using this equation, we can randomly initialize the position for the n Freibergs in the search space. Suppose we have here 5 Freibergs, and for 5 Freibergs we have the position for the first Freiberg x1, second Freiberg x2, third x3, 4 x4, 5 x5. Then we have the design variables D. We have 1 to D, that is the total number of design variables, or you can see the search dimension. So for each firework we will initialize the position. So this is the position for the first firework, second, third, fourth and fifth one. Next we will calculate the fitness value for each firework, and then we will check whether the current iteration is less than maximum iteration or not. For example, suppose maximum iteration we have 500, current iteration is 1. Right now condition is true. We will move to the next step, set of n fireworks. So here we have 5 fireworks. When fireworks are set off, you can see here spark is generated, and here we have 2 type of explosions. So next we will calculate the number of sparks that each firework yield. For example, you can see for the first firework we have 3, we have 4 spark. For second firework we have 7 sparks, and for fourth firework we have 4 sparks. Now we will calculate the number of sparks that each firework yield, and we will obtain the position for the each spark, as we have the virtual firework, virtual spark, virtual explosion. So we will calculate the number of sparks and next the position for each spark. So in this algorithm we have 2 type of explosion, good explosion and bad explosion. In this step these 2 explosion behavior are simulated. In the good explosion, different sparks are generated, as you can see here, and the center of explosion is centered by the sparks. A firework with good fitness value can produce more explosion spark with small explosion amplitude, and in bad explosion only few sparks are generated. For example, you can see we have only 3 sparks, and sparks scatter in the search space. So firework having the lower fitness value can only produce smaller population with a greater explosion amplitude. As we know, exploration is the algorithm ability to explore the various regions of the search space to find out the optimal solution, and in exploitation we conduct the search within a smaller area to find out the optimal solution. So fireworks having the lower fitness value and large explosion amplitude is used for the exploration phase, as they can easily escape from the local optima, and the fireworks having the higher fitness are used for exploitation, and here we have the smaller explosion amplitude. So next we will calculate the number of sparks generated by the firework. So here SI denotes the spark, I means the total number of sparks 1 to n. M is here is used to control the number of explosion spark. So here this is the total number of sparks generated. So this parameter is used to control the number of sparks generated by n fireworks. By max, that is the maximum fitness value for the firework. So this is the burst fitness value. Fxi, that is the fitness value for any firework. So here this is a small constant that we can use to avoid zero division error. So using this equation we can calculate the number of sparks that each firework generate, and next we will use this equation to limit the good and bad firework explosion spark. Means to say, good firework cannot produce too many explosive sparks, and bad fireworks cannot produce too few sparks. So we will use this equation to limit the good and the bad firework explosion sparks. Here A and B, they are constant. SI, that is the spark generated, and we'll check here. Next we'll obtain the position for the sparks. For example, this is the firework and we have the sparks. So this is the virtual firework and we have the virtual sparks. So now we will obtain the position of the spark of firework. Here we have 2 types of sparks. So here, as you can see, we have two types of sparks are used: explosion spark and the Gaussian spark. Explosion spark is generated by the explosion process, that is the firework explosion process. Gaussian spark is generated by the Gaussian mutation. Here we will use two algorithms to obtain spark location. First, by explosion process, and that is this one. So first we will obtain the position of the spark by the explosion process. First initialize the spark location, then obtain the number of effective directions. Here rand is any random number that is between 0 and 1. D is the dimension. Next we will randomly select G dimensions for the spark. Then we will calculate the displacement. Here this is the amplitude that we will calculate. Then the location of spark for any firework is obtained using this equation. Firework explosion. So here the firework explosion procedure is simulated. Next, so when the location is generated, we will check whether the generated location is within the search space boundary or not. So here we will apply the mapping strategy to keep the spark location in the search space boundary. If there is any spark out of boundary, then we will map that spark into the search space using this equation. Here x min and max, that is the minimum maximum limit for the search space, and this is the spark generated. Here the percentage symbol represents the arithmetic modular operation. Next we have second algorithm that we will use to generate spark using Gaussian mutation. Here again initialize the spark location, obtain the number of effective directions randomly, select G dimension. Now we will calculate here coefficient of Gaussian using this, and then we will calculate the spark location. Then we will check whether the new location that is obtained is within the search space boundary or not. So here we will apply the map strategy again to check whether the new location that we obtained is inside the boundary or not. So here again using this equation, using this mapping strategy, we will keep the new solutions within the search space boundary. Next we will evaluate the quality again for the new solutions that we obtained. For the new solutions we will check the fitness values, and we will select the best location for the firework. So we will keep the best solution. So here we will calculate the fitness values, keep the best solution, and rest for the next generation. For example, we calculated the fitness value for the 5 fireworks. Next we will rank the solution as per their fitness value. Rank the best fitness value at first position and the worst fitness value at the last location. For example, third firework having the best location, so this is the best firework. Keep the best and rest for the next explosion. So we select n-1 for the next explosion in the next iteration. So here the roulette wheel process is used for probability of selecting the fireworks for the next iteration. Here RXI, that is the distance between location, is calculated using this, that is the fitness value for fireworks. FXI minus FXJ, and the K is here the set of all current locations. So when this stopping condition is met, we will stop and display the best solution. So we'll repeat this process until the stopping condition is met, and when the stopping condition is met, we will display the best solution that is found. When the stopping condition is met, we will stop and display the best firework and its position until we will repeat this loop. Set of n fireworks, obtain the position for the spark, calculate the number of sparks, their position, evaluate the quality, and then again select n-1 for the next iteration, check stopping condition. If not met, then again repeat steps, else display the best solution. So that's all about this video. If you have any questions, you can comment below. And thanks for watching this video.